Hi friends, welcome back to the sessions of DBMS. So last session we understood what is the meaning of candidate key and how to obtain multiple number of candidate keys. And we also discussed about what are prime attributes, what are non-prime attributes. Right? Now in this session we will see few things about super keys. So what is a super key? I gave you few important things. Super key is nothing but maximal closure, and one more, superset of candidate keys. And another one is every candidate key is super key, because the candidate key, when you speak, it is a minimal or a subset of your super key only. Okay. And the next one is a relation can have more than one super key for a given relation or for a given candidate key. How to do this? What to do this? So as I told you, a relation can have multiple number of candidate keys, right? So whenever you have multiple number of candidate keys, one candidate key must be primary key, other candidate keys must be alternate keys, and all the alternate keys and primary keys are subsets of what? Super key only. Okay. And now you may get a doubt, what is the meaning of alternate key? So alternate key is nothing but it is also candidate key only. A relation can have more than one alternate keys, but a relation can have only how many primary keys? Only one. And how many alternate keys? Multiple number of alternate keys. So alternate keys we can designate as, alternate keys are known as unique keys. Okay friends, now immediately need to understand what is the difference between primary key and what is another difference between the unique key. In primary key, no null, no duplication. In unique key, nulls are allowed, but duplicates are not allowed. Okay, this is the difference between primary key and the candidate key, primary key and unique key. And you see that primary key and unique keys are by default what? Candidate keys. Candidate key by default what? Super key. This is the relationship among them. Okay, just copy this. We will look at into super keys concept. Yeah, well friends, now let us observe superkey concept and how to derive multiple number of superkeys. For example, R is ABC, candidate key is A, find number of superkeys. The solution for this is this A is a what? Candidate key. As I told you, every candidate key is a what? Super key, right? Now tell me, this A has got how many combinations with your relation R? Two combinations. Because I know A as a candidate key, I can make the manipulation with other two attributes like BC. So, N of A, number of super keys is nothing but 2 raised to 2 options are there, then answer is 4 super keys. What are 4 super keys? This 2 is here only. What are 4 super keys? A itself is a super key. A with B is a super key. A with C is a super key. And A with BC is also super key. 4 super keys in this. Okay. Another example. R with ABCD. Candidate key is AB now. He is asking find super keys in this. The solution is N of AB has got how many chances? 2 chances with your R. So 2 power 2 is equal to 4 super keys. What are 4 super keys? AB itself is a super key. AB with C combination. AB with D combination. AB with CD combination. Okay? Let's copy them. Well friends, now let us look at into few other questions based on candidate key. I am saying The relation R with A, B, C, D. This time candidate keys are 2. A and B are the 2 candidate keys. He is asking find a number of super keys. The solution is n of A plus n of B, and there will be a common between them. Why? Because this is A candidate keys, these are B candidate keys. There is a common between them. That common you have to subtract. So n of A, how many combinations? 2 power 3 combination. N of B, how many combinations? 2 power 3 combination. N of AB, how many combinations? 2 combinations. So 8 plus 8 minus 4 equal to 12 super keys. What are 12? I will show you. The 12 super keys are, first let me write with A with B, A with C, A with BC, A with BD, A with CD, A with BCD. 1, 2, 3, 4, 5, 6, 7. One more is there. That is A with BC, A with BD, A with CD, A with BCD, and A with D. Okay. And now B common. So B with A, B with C, B with D, B with AC, B with AD. 1, 2, 3, 4, 5, 6, 7. B with CD, B with ABC, ACD. What are common in that? Total 12, total 16, 8 and 8, 8 and 8, total 16 minus 4. What are 4? Common. ABBA, this is a common, and ABC, BAC, this is a common, ABCD and ABCD, this is a common, and one more, what is that? ABD and BAD, that is a common. So 4 common, so answer is 12. Okay, this is how to obtain number of super keys. Okay friends. And another example, this is the last example. I say R with ABCD, candidate key is AB as well as CD. He is asking find a number of super keys. So n of AB plus n of CD minus n of ABCD. Okay, there may be a common between them. So how many chances? 2 chances. 2 chances. How many chances? ABCD, no more chances, right? 2 power 0. So 4 plus 4 minus 1, that is equal to 7 keys. What are 7 keys? Let me start with AB. AB with C, AB with D, AB with CD. That's right. CD combination. CD with A, CD with B, CD with AB. What are common? This is common. And how many? 7. 1, 2, 3, 4, 5, 6, 7. That is the answer. Okay. Just copy this. Yeah. Well, friends, we have successfully completed functional dependencies, attribute closures, derivation of the candidate keys, and also identify super keys. Now, our next task is normalization concept. Okay. So, normalization plays very important role in real time as well as in the interviews. So, in Schema Design, two parts. Your schema design is a two parts. One is a functional dependency and the other one is normalization. So in this we discussed FDs, attribute closures and candidate keys and alternate keys and super keys. Now we will discuss about normalization. Okay. So what is a normalization concept? Normalization is going to give you a redundant free and anomalous free database. Okay. If normalization is not done, then we ultimately suffers with a what? Redundancy as well as anomalies. Okay. Just write a point. Normalization. Normalization is used to obtain good schema. Next point. A good database design. Good schema is nothing but database design only. A good database design always provides the following. Number one, redundant free database. Number two, anomalous free database. Number three, avoids inconsistency. Number four, provides data independency. So they are the main advantages of what? Normalization. Okay. The main intention of normalization is nothing but reducing redundancy. This is the main intention of what? Normalization. Because redundancy suffers from anomalies, insertion, updation and deletion. And redundancy also suffers from inconsistency. Okay, how redundancy is creating the problems, I will show you. First, let us see what is redundancy. Redundancy is nothing but what? Duplication. Now you see, there are few varieties of redundancies. One is attribute has redundancy. Two is tuple has redundancy. Three is table has redundancy. Fourth one is file has redundancy. Attribute level, tuple level, table level, file level. Okay, I will show you one sample example. There is A and B. A1, 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 B1, B2, B2 or B3. This has got a redundancy. This redundancy is known as what? Attribute level redundancy. Because attribute A has got redundancy. Okay, just copy this. You want to see, friends, now what are the reasons for redundancy generation? The reasons for redundancy generation is two. Factors for redundancy generation. Number one, functional dependencies. Number two, multi-value dependencies. How functional dependency is going to give you redundancy, I will show you. Redundancy through FD. Okay. Now I am saying there is a relation R which has got AB attributes. I want to prove A tends to B. So this itself is going to give you some sort of redundancy. How? Let us see. A1, B1, A2, any value you can give, B2. But you see, whenever I repeat A1, what do you have to repeat? B1 to satisfy A2B. Whenever I repeat A1, you have to repeat what? B1 to satisfy A tends to B. Therefore, what do you understand here? The A value is replicated. Simultaneously, B value is also going to be replicated. So that's why functional dependency is what? One of the factors for generation of what? Redundancy. Okay. So now my question is how to control redundancy which is caused by functional dependency. The only one, what is that? Normalization. So first normal form, less redundancy as compared to unnormalized. So still you can able to reduce in second normal form less redundancy as compared to 1NF. Third normal form, less redundancy as compared to 2NF. BCNF, redundancy is how much, friends? 0. You will see wonder. We start with some kind of a duplication, but once you reach to BCNF, the redundancy becomes how much? 0. This is the power of normalization. Okay. How it is going to be 0, we will see. In the upcoming examples. Okay. So copy this once. We will see what are the normal forms we have so that you could able to avoid the redundancy which is caused by functional dependencies. Okay. Copy. Yeah, look at friends, how you can able to avoid redundancy and how you can bring it to zero from huge redundancy. Just you understand this. I'm saying like this. What is the meaning of first normal form? Okay. A relation R is in 1NF if and only if it has single and simple values. Next one. If a relation has multiple values, then convert into single values. To convert into single values, key must be composite. How? Earlier primary key plus multi-value column together forms composite key. As I told you, 1NF redundancy less than unnormalized. Okay. For example, there is a table student. It has got student number, student name, course, S1, S2, X and Y, C, CPP, Java. You observe carefully, this is the primary key. Is above student table in first normal form? The answer is no. Because of what? Multi-values. In which column? Course column. So what you need to do? Therefore, convert into single values. How to convert into single values? I gave you these steps. SNO, SNAME, course, S1 XC, S1 X C++. S2 Y Java. So I have divided, these are divisible values now. I have divided into indivisible form. This is one row, this is another row, this is another row. So here what happened? The key, because earlier this is the primary key, right? What is your primary key? S number. You want to convert into multiple values, the key must be what? Composite. Why? Because if I am saying this is the primary key, then duplicates are not going to be allowed in that. Therefore, it must not be the primary key. And your primary key is going to be what? that primary key and your multi-value column together is a primary key. Key must be composite. Our given primary key and multi-value column together is a what? Composite key. Now this is your composite primary key. Okay. So S1X is a unique value. S1X is another unique value. S2Y is another unique value. This time we see the uniqueness among tuples of SNO and course combination. Okay, just copy this. Yeah, well friends, how to convert from unnormalized into 1NF? It's a very simple process. How to convert from unnormalized to 1NF? It's very simple. What I said, convert multi-values into single values. And your key must be composite. Okay. Let us make it generalize this. I say relation R has ABC. A is a primary key, C is a multi-value. Is it in 1NF? The answer is no. Why the answer is no? Because what? C is a what? Multi-value. So therefore, what is the requirement? Convert into single values. Convert into single values. So how to convert into single values? I said key must be composite. So therefore your R is a what? A is your primary key. What is a multi-value column? Composite means what? Your primary key plus multi-value only. And separate B from there. Now this is your composite primary key. Now the above R is in where? 1NF, because no multi-values. Okay, one more example. So R of A, B, C, D, A is the primary key, C and D are multi-values. He is asking convert to 1NF. How to convert to 1NF? The solution is what, friends? R is ACD, B is separated. Why R is ACD? Because A is your primary key and C and D are what? Multi-values. So what I said, combine all of them together, it is a what? Composite primary key. So this is how you can convert from unnormalized into 1NF. Okay, copy this. Yeah, well friends, this is how you could convert from unnormalized into first normal form. Still, first normal form is not completely free from redundancy because it suffers from partial functional dependencies, hence it leads to redundancy. How to control it? Just by converting 1NF into 2NF, we will see in the next session. Thank you very much.